We can start with this first lesson. The first lesson is about is a kind of introduction to robotics. It's a very general one, and toward the end we will go to something that is closer to our problem. So first of all, what is a robot? A robot is a device, so it's something that is mechanical, electronical, things like that. That has sensors, so receives data from sensors, so gets some information from the external world, and based on this information performs a task, moving something. So it's something relevant, the fact that there are motors and we have to move something. And okay, we think often about robots as autonomous agents, autonomous entities. This is not true always. Many robots are called robots, but they are not autonomous. But we will see something about this. So in general, we have something that is a device. We have a kind of perception for this device. And we take a decision about what's happening around. And then we decide what to do. This, for instance, was a head that we made for a Triennale exposition a few years ago, and it had to detect people. And once the person was close by, we decided to tell a story, tell a short story about AI, about artificial intelligence and robotics. But the same framework applies also to another robot like this. This is it's called a photovore. It's a robot that lives by eating light. So through some solar cells, it charges an internal capacitor. And when the capacitor is charged, is discharging the capacitor on a motor. Which motor? The motor that brings it either on the left or the right toward the light, because it has sensors that detects the direction of the light. So it lives with light, no batteries in this case. This is another one we are developing together. It's a robot for autistic children. And again, this robot has some perception, has distance sensors, takes decisions, and upon the decision it takes, it makes some actions. So, for instance, it would like to play. It goes toward this child and says, "Okay, please, would you like to play with me?" If the child is gentle and maybe caresses it or embraces it, it's okay, and it reacts by saying, "Okay, I would like to play with you." If it is not gentle, it happens with this kind of children, it has a reaction that maybe I'm afraid, I go away, or maybe I'm angry, and with red lights it's doing something strange. And again, it's always the same thing. So perception, decision, and then an action. And this was a soccer player, a robot soccer player. There is a world championship for soccer. Robot soccer. Again, in this case, perception was able to perceive the other robots, the ball, and the field, the position in the field, and take a decision, and finally was able to play a game with a team of other robots. But how do we imagine robots? So robots in general are artificial intelligent entities, intelligent, autonomous, able to communicate, interact, sometimes dangerous. We have seen many movies where we have dangerous robots. But all these kind of things are just movies, so these are not true. It's something that happens only in the fantasy of the writers. Robots are something different now. Let's start from why they are called a robot. That gives an idea of what is a robot. Robot is a term that was taken by a writer for a drama. and means hard worker. And in the drama, the robots were generated by a scientist to work instead of humans, and so to relieve humankind from hard work. Everything goes well until the daughter of the scientist decides that it's a pity that these robots cannot have emotions, cannot feel their state of slavery. So suggests to have them feeling these emotions, and this is damage for everything, because robots say, okay, so we wouldn't like to be slave, we would like to be free, so kill all the humans, including Rossum, including the only person that was able to keep them alive. So at the end of the drama, everybody dies, as in a Shakespeare drama. And okay, this was coherent with the situation in those years. We were just about at the end of the First World War, and the situation was critical in all Europe, and everybody was very pessimistic. But this was successful, and okay, the name robot started to enter in the fantasy of writers until Isaac Asimov took this name as a basic of some discipline, which is robotics, in a novel, and it says, okay, there are robots, artificial entities, that have to satisfy 3 laws of robotics. 3 laws of robotics, then augmented with a law 0, that started to influence all writing in science fiction for many years from then, introducing philosophical issues in writings, which are very interesting. Briefly, the laws are these ones. So a robot may not harm humanity, or by inaction allow humanity to come to harm. A robot may not injure a human being, or through inaction allow human being to come to harm, except when this would conflict with the previous law. So a robot must obey the orders. So a robot is still a slave, should obey the orders. And a robot must protect its own existence as long as such protection does not conflict with the previous laws. So the robot in this idea is a kind of slave again that can try to survive, but it should obey to humans and possibly do not harm humans. This is the first robot in the movies that was designed to protect the daughter of the scientist, which actually was, who actually was then protected by a nice Star Trooper guy, and so the robot was useless. But anyway, this was the first time that we had a robot in a movie. The hard reality is that no robot can satisfy these laws. So because no robot up to now is able to understand what this law means, and even if they could understand, they are not able to detect the right action to satisfy, to follow them. But we have a lot of robots. Robots are used as tools, aids to do tasks in support of people, or instead of people when this is dangerous, maybe or is too heavy for people. Most robots have no autonomy, or a short or small autonomy, just a few autonomous abilities, and repeat their movements. Many of them are teleoperated, but some are autonomous. The development for the next future is that, as I said here, I can envision a future in which robotic devices will become a nearly ubiquitous part of our day-to-day lives. And this was said by Bill Gates a few years ago. And this is something that is happening in the market now. In 2005, we had some industrial robots working in production plants. We have some robots used in space and safety, and some service robots. This is the first year where the last two overcome the first for number and market share. And then things went like this. We have a little bit crisis around these years. And this is the expectation for industrial robots, for space and safety, and finally for service robots. So service robots are expected to explode in the next years in, somebody says, €1 trillion market. These are the industrial robots. Industrial robots repeat in always the same things, but these things are something that we would like to avoid. So we would like to avoid to solder, move heavy things, and everything that is hard to do can be done by robots. And we have also situations like this. This is sorry, that's not so clear. It's the storage for Amazon. Amazon bought a company for $700 million. Everything is managed by robots that go around, take the shelves and bring the shelves to the operator, which does the only thing that is difficult for a robot, so taking things from the shelf and packing them. So this is done here. In this way, the robot is rising the shelf and then is taking it away. So the storage is dynamic, everything changes. They move in streets, and then they have highways. This is a little bit accelerated. The idea is that we have these robots. This is taken from an interview. We have this robot that can do something like that. So make it possible to have the person having the right things at the right moment to put in the package. And this is done actually like this. So the robots come there. You see up there that here we have an operator filling the things, and then everything is returned into storage. So these are industrial robots. They are programmed to repeat always the same action. Sometimes they are teleoperated. They work in environments that do not change. So everything is always the same. They are accurate, fast, and reliable, and run without failures for a long time. They are industrial products. They should work because production should go on. They are expensive. They cost a lot. Second section of the market is safety. Safety means military. So we have automatic vehicles, unmanned vehicles, actually, both flying or on the ground or also on sea. We have robots for exploration. That one was an Italian one for exploration in the Antarctica. This for exploration in volcanoes. And this was exploration on Mars. Most of them are not autonomous. They are teleoperated. The autonomy in the UAV or UAG, unmanned vehicles, is mostly dedicated to follow a target, to reach a target. But the person is always deciding what to do with his target. So there is always a person taking the decision of killing people. And here we had a first example of autonomy in a far space, in Mars, we had this robot that was going on his path to detect something on the ground, and was teleoperated from Earth. But teleoperation takes 8 minutes to give a command and 8 minutes to give back things. And when this came close to a big stone, they took something like a few weeks to move it away from the stone. So the second one was programmed so to have some autonomy to overcome this kind of problems, so obstacles were avoided automatically. And this is an automatic autonomous vehicle done here at Politecnico by our lab and the automation lab, the Merlin lab. It works automatically by taking information from sensors. It brings also a quadricopter that is intended to serve as a basis for the quadricopter that has a very short range in order to detect things that are around. So you can launch the quadricopter and see from the quadricopter what happens, and also has a camera on board. But everything is done autonomously. You can take the control of the vehicle, but it is able to reach a target by deciding its own way. And this is the vision from the quadricopter. This is another vehicle. It's a bio-inspired transporter. It's partially autonomous in the sense that it's able to manage the problems it may have with the ground. In this case, you see snow. Then in a moment, you will see ice. Here is on ice. You see that it's able to manage to stay also on ice. This is a quite old movie. It's since a few years. Now the same kind of things are much smaller. They are different size. Some are very small and can run up to 100 kilometers per hour. Others are small and can go around also in offices. Others are very big and can bring a lot of weight around. These were designed to bring weight in strange situations, in places where it's difficult to have vehicles with wheels. All the other robots are for service, and these are the ones that will increase their presence on the market in the next years. We have home appliances, we have healthcare, we have entertainment, and some of these kind of things. So we have things like these cleaners. These are more or less autonomous. It depends on the cleaner. Some of them have a camera to decide where to go. Others are just going until they reach a wall and then go back. So they go more or less randomly. The same applies for these lawn mowers, where we have the person that is enjoying his newspaper instead of cutting grass, and there is a nice robot that is cutting grass for him, so that's okay. And also the washing machine there is maybe something that is not like a robot, but it is a robot, because many of these appliances now are taking decisions upon something that they are able to detect. So there are washing machines that have just the start button, and they are able to detect what is inside and decide the program to wash things appropriately with the program. Healthcare. We have surgery robots. They are very precise, and they are teleoperated. You see here the surgeon, here the robot, and here should be the patient. This is just to recall you that you have the possibility to see the nice experiment that they do to train the surgeon. They have to peel a grape with these tools that are usually inside your belly or inside your body. So in order to train, you have to reach the ability to keep the peel, keep the peel, and peeling this kind of thing. It's something that is nice. But they are teleoperated. Then we have prosthesis. They are usually body-driven. So the sensors in this case take information from the neural or the muscular activity of the body and are moving parts that are missing in the bodies of somebody, as in this case here. We have this guy that has lost both arms, and it can control with the muscular activities of the chest the movement of the arm, which is actually a quite complex robot, and so he is able to do things like this and gains again the ability to be to do things autonomously at home. And then we have robots for rehabilitation, for instance, bringing people around, such as with the autonomous wheelchair, or this kind of things that can be put on if you are not able to drive your muscles of the legs and used to recover possible injuries for neural problems. And these kind of things are around. Let's go to entertainment. Entertainment, we have toys and games, a lot of toys and games. Every Christmas we have even more toys and games that refer as robots. A lot of them, they can be teleoperated or autonomous, and they have to support a game activity that engage the user. So we would like to have the user engaged in some activity which is interesting. So on the right, you see there one of the robots we use to develop games. We are developing games since a few years also in our lab. And on the left, you see something that was announced a couple of years ago as the new revolution for robotics at the Apple developer conference from the Apple CEO. And in this case, we have autonomous cars that can run on this track freely, autonomously, taking decisions. And you can take the control of one of the cars with an iPhone, but the others still run. So it's a video game in the reality. We may have robots for exhibitions, which may be autonomous or teleoperated. We have these robots that should engage the user, so should tell tales, should tell stories about the exhibition, but then they have to keep the attention of the user active. On the right, again, we have something that we have developed, and we will see as an example later. And on the left, one of the many robots that are used in mostly in technical museums. And then we have companions, which is the goal of this course. Companions that should be autonomous, helpful, engaging. We will talk about this in a moment. They are the most difficult thing to do in this field for the moment. So companions, what we have as companion. We may have pet robots, so robots that are considered as pets, and you are interacting with these robots as pets. We have there, on the left, we have Paro. Paro is a baby seal that has very many sensors on the body. You can caress, you can move, interact with the touch with this. This is moving, a little bit. It's not running, it's not going around, but it's moving the head, is making smiles and this kind of things. Is humming, doing some noise, something like that. And it's engaging old people or also autistic children. It's used in many therapies as a pet, which is reliable and easy to find reactions. So it's not something that do something unexpected. It does something that is always expected. Now here we have Furby. Furby, you may know Furby. It's again something that evolves with the interaction. And then we have one of the versions of Aibo, which was a product of some years ago. Now has been dismissed because of the market. So this stuff here costed something like $2,000. And it did something very similar to the one that we have there, that last Christmas was around for $79. From the user point of view, it's more or less the same. And so it's true that this is a lot of technology more than that one, but for the user point of view, it's not a viable product. Something else are assistive robots, which are intended to bring some assistance to elderly, to people. Assistance in many senses, help at home, help a child or play with child, bring things. And we have a lot of stuff like more or less like this. They are not satisfactory for the moment. So they are doing things which are not related with the cost they have for the moment. Here we have an example of the evolution. This is a product that comes from a European project, from a set of European projects, actually. This is the third version. Was expected to go around at home with an arm which is actually an industrial arm. So something very big, heavy. It's about 200 kilograms. And okay, you see, this is the shape of this object, and the new version is this one. A little bit changed. And we will see them moving. They are doing interesting things. Another kind of emerging companion, which is a strange one, is this kind of things. So things that you can put on the shoulder like a bird. This case is a person, but we have seen a bird at a maker fair. But let's see a little bit what is a robot, what is inside a robot. So how can we make a robot? We take this robot as an example. This robot has sensors, kind of mind, and a body. This robot is intended to go in exhibitions, go around an exhibition, look for people, go closer to the closer face he can recognize, talk with these people. By detecting the movement of these people, if people is nodding, saying like that, is showing interest. So if the person is showing interest, the robot asks to follow it to the booth of the company. So it's bringing people around in the exhibition and bringing people to the booth, to the stand of the company. This is the aim of the robot, and this is what it does actually. But we will take this as an example of how a robot can be done. The sensors. So we have the three aspects, which are sensors, mind, and body. Sensors. Sensors provide data relevant to support the task performance. So what we need when we talk about sensors is the information that we need actually to perform a task. So if we have a task, we define a task, then we understand what we need to understand from the external world, and we have to have the sensors able to provide this data. And this means word modeling, so detect things, recognize things, conceptualize things. So try to elaborate this data in order to have a conceptual vision of the world, a conceptual idea of the world. Self-localization, knowing where you are. Something about the internal status, starting from batteries, but then from other position of the body and everything. The action, so decide the action, and the interaction. So sensors are supporting all these kind of things. And actually, they are the channel we have to take information from the external world. In this robot, we have a Kinect. Do you know what is a Kinect? Kinect is a device used for games that has a camera, as a device used to detect the user playing in front of this and in front of a screen. And while the user is moving, Kinect is able to detect the movement of the user and to provide also a 3D image of what is in front. So it gives the distance of each pixel. Instead of having pixels with colors, you have pixels with a distance. So each position, you have a distance. And this is a product that is very cheap. And it is used for gaming, so it's not used for robots, although many people is using that product for robots. So we have a Kinect. It is used for self-localization, mapping, and interaction. Self-localization and mapping because it provides this distance to objects, so it's possible to detect the distance to the walls and the other elements of the environment, and from them you can build a map and know where you are. And for interaction, because it's used to detect the movement of people and how people is interacting by the gesture of people. Then we have sonars. Sonars are used to measure the distance from given directions. And so these are tools used to get the distance from something that we don't know exactly. They are used for safety reasons. If the Kinect fails, at least we are sure we are not hitting a wall, hitting a person. We keep a distance to the things. And then we have encoders for the motor rotation, so you know how much you are moving and how you are moving. And we have some information about the battery. And these are the sensors available on board. You might notice that we don't have any microphone because in this kind of environment we couldn't understand anything. So we cannot understand natural language, but we can understand if people is interested or not, and this is enough for this task. In general, these sensors provide some electrical coding of some external quantity, some physical quantity. We may have cameras that produce an electrical signal according to the enlightenment of each of their pixels, of each of their components of their sensors. Here we have strange camera. This is an omnidirectional camera that looks on a mirror which is up over the camera there. And so you can see 360 degrees around just by taking an image. This is something nice. And the other one is a stereo camera providing this triangulation, so the possibility to measure the distance of the object. Then we have distance sensors. You will have distance sensors also. Here is a laser sensor that is able to take the distance every degree for maybe 270 degrees around, so it's very precise. And you can have this kind of maps from this scan It's possible to have very precise maps. We have other sensors such as sonars or infrared sensors, which are less precise, but still interesting to detect the distances. Then we may measure acceleration and movements. This is a device, again, used for games, but inside we have acceleration and movement measurements, as in our phones. You can move the phone and detect how this is moved because you have these sensors on board. Then we may have pressure and touch, so you can touch and sense the pressure. For instance, we have used that to understand whether our robot for autistic children is caressed or is punched or what they are doing with our robots. And then we may have also an artificial nose or taste. We can do strange things with robots, and many kind of sensors. But once we have information from sensors, we have an electrical signal, which may be analog, so we may have something that changes with time, or maybe a number, so digital. And we have to interpret this information. So this is just a signal, electrical signal. We have to understand what is this. So for instance, we have a camera. Digital camera provides a set of numbers, a matrix of numbers. So we have a rectangular matrix of numbers, and each point, each box in the matrix contains three numbers, which are the three numbers that identify the color of this point. So the color is identified by, for instance, the quantity of red, blue, and green components of the color. Why red and blue and green? Because in our eyes we have sensors, which are neuroreceptors, which are sensible to red, blue, and green. So we have done something which is very similar to our own abilities. We may say that we have numbers, so we have to decide what to do with these numbers. So we have a matrix of numbers. What can we do with numbers? We can say, okay, maybe we have similar numbers, a similar set of numbers, and we say these are similar color. Okay, so this can be used to say that we have blobs of the same color or similar colors. Or we may say differences. We see differences, strong differences from one point to the closer point, and this is a line. If you look at these things, you have in every environment you have strong differences of colors, and these are lines which are around, so we can interpret images as lines. And once we have this information, such as color or lines, we can try to understand the shape of the lines, the shape of the colors, associate them to known things about the objects, and so at the end we can detect the object and detect possibly the position of the object, and then finally understand what's around, understanding the scene. This is a quite complex process. And once we have this world model, we can decide what to do. For instance, this is an orange ball. And if we take a pixel, so an element of this image, I will say that pixel is identified by a lot of red. 255 is the maximum value for this intensity. A lot of red, some green, and no blue. The green possibly comes from the reflection of the field that is around, so this is green. And then this is a little bit darker, but the proportion is more or less the same. This is a little bit more light, and we are losing the proportions, and so it's not the proportion that we have to take to understand the color. And here is again a problem. And here is something that we cannot consider. When we see this ball and we are asked what is the color of this ball, we say, okay, this ball is orange. We don't take care that there are black things on it. But the robot, the sensor, detects black things. So it's something that is also relevant, and it's there. Moreover, when we take the image, we not always have the image as nice as the one that we have just seen. We might have images like this, for instance. This is the ball that we see if it is far away. Something very difficult to understand. But we can do something, and we can work on these kind of things. We will see some sensors later on, so you will have the ability to work with them without any problem. Let's go to the body. The body is aimed to provide a physical support to perform the task. So again, the main point is a task. What is the task? We decide what is the task, and then we take decision about the shape, about the body, about what the body is able to do. This means movement, shape, the way you interact, and this kind of things. In this strange robot, we have many elements that are used to produce a kind of emotional interaction. We can move eyes, move eyebrows, move head, move also the neck, and have a lot of movements that are aimed at having an emotional interaction. We have a loudspeaker, so we can talk. And we have motors with omni wheels. Omni wheels are this kind of wheels. You can see here what is at the very bottom of this robot. There are 3 wheels. Each wheel has a kind of small cylinders on the border. So if you take the wheel that normally goes this direction, if you take the wheel and go this direction, it doesn't have any resistance, so you can push also on the side of this robot. So you can put these wheels in this way and have a robot that doesn't need to steer. It can just go like that with no problems of steering. No limitation, it's more free. And this is a choice for the body. And then let's come to the mind. The mind, we have word modeling. So this means understanding what's coming from the sensors and try to decide what is there. So the sensors provide some information, and we have to elaborate this information to build a model of the word. Again, a model that is useful for the task. This means classify objects, recognize objects, localize objects, track objects, by taking maybe information from different sensors. And this is something that here is made by, for instance, elaborating the image. We can detect the face, detect the movement of the face. Here you see a part of the elaboration. Here we have detected the eyes and the proportion of the eyes, the position of the eyes and the eyebrows in the face, and we can detect that the face is doing like that. So if one is nodding, it's doing something like that. And this is enough to understand something. Or here we have something for localizing the robot. The robot has a map, and you see here in this here, here. These are obstacles detected, and this is the map that the robot built before. This is where the robot would like to go. And here is a cloud of possible positions of the robot. Since the robot is not sure about its position, is elaborating some information and say, okay, I'm around here. And so as far as it detects more things, it can make this estimation more precise. But in general, it's enough to navigate, to go around in this environments. And then track people also. Then another important thing is that this is the model of the world. We can detect things and understand what's around. Then we have to decide what to do. So what to do is a behavior of the robot. And we can have behavioral models to do the single things that the robot can do. We may have enabling condition for each behavior, opportunity condition, so it is the case to do something or not, and action proposals. For instance, here we have a set of possible behaviors for this robot. One behavior would be detect a person, so go around and look for a person. Another one is go to the person. Once I've detected the person, go there. Another one is tell a story. Another one is leave the person because he's not interested. Another one is accompany person. Another one is thank the person once we have brought the person to the stand. And so these are all possible behaviors which correspond to some pieces of software that implement this behavior. And each of them has some conditions that say, okay, if I'm not talking with a person, it's the case to detect a person. But if I'm talking to the person, it is not the case to activate this behavior. So we have conditions that says if it is the case to do the things or not, to do what things or not. And then we have sensors that are providing data. We built our word model, and then from the word model we can produce information for this activation and for the decision that they have to take. And then we compose all this decision, and finally we get the action, the final action. So the main cycle is something like that. And this is something that we will do also. Planning. Planning is another activity that can be done. Means plan what to do in advance. So we need to know the possible effects of actions. We need to reason. And then we have to execute the plan and decide whether we are following the plan or if something strange is happening. And here, for instance, we have a situation where we have our robot here that has detected this obstacle, and he has to go here in this position. He knows that, and so he plans to go on a straight line, like this. As it will come close to this person, probably this person had moved, and if this person has gone in the path, probably this will have to replan and make a turn here, something like that. This is planning. This is decide what to do because I have a goal to reach, and then upon the goal, check if the goal is achieved or not. Finally, at the end we will have a robot with a character. So the aim of this course is to have a character for this robot. Because these robots are robots that are entering a society, they will interact with people, they share the life with people. And if you share the life with things like this, probably after a while you are bored and you say, okay, who cares about these robots? So I'm not interested about them. It's clear that a robot, is not a human being, is not a pet, is not a biological entity, but it is interesting if we can recognize in the robot something that we can appreciate. These kind of robots with all these expressions are more interesting than this kind of robots where you cannot have anything. And so this is the way we will go in this course. Some examples you may have seen already from the website, where you see that here we have many objects, and we will have also a robot. And you see that also without any noise, without any sound, you can get some feeling from this robot by the way he's moving. So this is one of the goals we will have. So it is able to interact with people. In this case, it was stable, but it's always moving. If it is not moving, it's an object, it's nothing. It becomes alive in the moment it's moving and is somehow doing gestures that are useful for interaction, to make interaction interesting. Apart from what happens on the screen. Here is telling a tale and saying, okay, yo. Then something happens and this, where are you? And, okay, found it. This is another one. You probably have seen it, but I would like to point out the interest of this simple thing. So this is just a useless box. It's a useless machine. You have to turn it on, off, and turns off and on, and so. You see, something is happening there. At this point, I would be bored, but okay, that's changes. So the interesting thing is that something is changing, is introducing a surprise, is doing something new, which is interesting because it's challenging the person, not too much, but it's still doing something that is not just boring, just the same thing. And then, okay, final surprise, this is a white flag, and say, okay, I surrender, but anyway, I close that. And here is another example of the shape of the body and the movement also. How much these are important to determine a character, to see a character. This is a robot bash. You see this robot, this is very aggressive, and this one is not very aggressive. And this is a Robo Wars. It's an actual competition. This is an advertisement, of course, but you see what happens at the end. So this is surprise, but let's see again and try to understand what's happening from the emotional point of view. You have the impression of this guy, which is very, very dangerous. And this is nothing. As often, it's also tilting a little bit as problem in moving. But as a surprise, and this is notice the time of the surprise. So it's moving, this kind of thing. Everything is changing, it's nice, it's clean inside, it's something very different. And then the final surprise. Of course, this is just an animation. Not possible to have these kind of things, but it's interesting. And the last one is Plio. Plio is a robot that can move a little bit. Notice the kind of movement. So it's always a very smooth movement. Here is a little bit more nasty. It's reacting to sensors that is here and doing things. It's not such unexpected or such strange or such different. So after an hour you have experienced everything you can do with Plio. But anyway, it's something that can be interesting to see at least a little bit. Of course, it can stop here. But it has some problems on the back if it goes on the back. So when you're here, you can go back, just lose any possibility to be real, to be understood as a real. In general, we have also different materials and solutions and situations. Here is a robot that goes around. This stays on the desk. This goes around on the desk. This doesn't move only the head and the arms a little bit. This is as a face, is moving a face and doing this kind of things. So there are different situations where you can play with these companions. And we have different materials. Most of these kind of things are plastic, but some are fur, some are foam, some are different kind of things. And some have pre-programmed things like this one. This is moving a little bit these parts and can dance, can talk with you, can say this kind of things, more or less like that one. Here you have a phone on top, and so you can have any program on the phone. You have just things that is moving, is perceiving something, and you can do a lot of things because of this power on board. And then we have something about the function. All these robots have a function. This should bring things, this should bring people, this should clean, this should help people, this should interact with people. And this is the function. And then we need, or we may want to have a mood for these robots. A mood that means, okay, if I see this one, I don't feel any sympathy for this one. I say that the strong one is doing something maybe strange, but it's not something I feel in agreement. With this one, I feel automatically in agreement. Well, this is neutral, but if it is the wheelchair where I live for all my day long, maybe it would be interesting to have something more than just a wheelchair there. And also this, I would like to really to see a cleaner like this, that when I go back home and say, okay, I'm sorry, I couldn't finish my room. Can I go on, please? Or something like that. Could be more interesting than just having this stuff going around. An important thing is that you should enjoy interacting with your robot. It's important, because otherwise the market will not accept the robot. Should be interesting. So this is an example of a companion, one of the things that we have seen before. This is an official presentation. You can see from the official presentation what is the approach for this companion. This is this object. It's Haushaltsassistent. It's a German product, of course. And you see it's having this tablet going around. But also these people, you can feel these people, this person, which is one of the designers, that is not feeling comfortable close to this robot. You see that it's big enough. This arm is very heavy. The robot is doing something, of course, but it's very, very slow. It's something that is not really useful. And it costs something like 200,000 euros. But the same project, the same set of projects, so the same company, let's say, is doing the next step, and this is the presentation for the new one, which is not yet ready, but this is at least the presentation. And you may notice from the presentation the kind of approach and the kind of robot. This is a different robot. You may notice here the safety button in the front and the back. You can always push the safety button to stop the robot. Okay, this is just a presentation, but gives you an idea of. Notice this unfunctional movement while it's going, but is somehow showing some emotional recall, something. And then finally, okay, I was going to give this rose to the user, and he's happy, she's happy, and okay, yes. Maybe too much, but okay. Oh, he is happy. Notice the shape, the kind of movement, the kind of smooth movement, but at the same time, something that, you know, there's also this kind of movement, smooth movement. So we can engage the person, have a role, so a relationship, you can have a pet, a butler, a friend. We have to decide what is the companion with respect to this person. And if we would like to have this companion for a long time, we should be able also to have a surprise for this, or by changing things or being able to do many things. So this is not the case of any robot. This, for instance, is a very, very nice robot. You may have this movie also on the website. But it's just moving for the music. So after a while you say, okay, this is dancing, okay, nice. That's all. Okay, so at the end, these are robotics companions. If they are products, they have been designed for the user, being robust, cost-effective, and this is very important. Easy to build and maintain. And how to do this kind of things, so we will see a little bit in this course. So we will try to do something following these kind of things. So that's all for this presentation.